So that way. Okay, let's go. Okay. So here's on the x-axis, which is going to be the first column, you're going to write the mass of the sugar, right? Varying from 2, 5, 8, 11, 14. And on the second column is going to be your density column. Okay, where they're increasing the density. So you're going to go ahead and highlight the both columns. And then you're going to go to insert and going to go to charts. And then you click the first one, that's going to be the scatter one. Okay, so scatter, and always when you are drawing a chart, you have to have the chart title. So you can write down density of sugar solution versus the mass of the sugar. Also you want to write down the, you want to label the axis. So your axis is going to be here. You right click this plus, you click the plus sign and go to axis title. So you can label the axis. Y-axis is going to be density of the sugar solution along with the units grams per milliliters, and then the x-axis would be your mass of the sugar solution in grams. Okay, so and then after you have your data, we want to draw a trend line. So you go over here and then you click trend line. Okay, and what's important for us is the equation for the graph. So you're gonna go here and then right click and then you click format trend line. Okay, and then you will have this window here. You're gonna scroll down and then we want the equation. Without the equation we cannot do anything with the graph. So you're gonna click display equation on the graph. So you need this number, y equals 0038x plus 0.9941. Okay, so I'm going to go ahead and write down that y equals what is it? Can we see properly? 0.0038x plus 0.9941. So this equation you have to write on your handout. Also you want to print this one and attach to your report sheet. Okay, now let's see what we need to do after we get that. Use your calibration curve to determine the mass of the sugar in 100 milliliters of each soda sample that you studied. So how do you do that? So what do we have here in Y? It's the, what is Y? Density. And what do we have in the X?
Mass.
X is the mass. So Y is going to be the density. And X is going to be the mass. So let's see, for the soda sample we got the density. I'm just gonna pick a number that within this range. Let's say that's going to be 1.028. Density of the soda 1.028 density. Remember we can calculate this amount, right? You agree with me? You can calculate it. Now if this is the density that we got for our soda sample 1, how do we calculate the mass of the sugar in that soda sample? How can we calculate that? So remember our equation is y equals 0.0038x plus 0.9941. Correct? And let's assume this came to be the density of the soda sample 1. So how do we find the mass of the sugar in this soda sample? What do we need to do?
Plug that in for Y.
You plug that into Y. So 1.028 equals 0.0038x plus 0.9941. So can we find out our X now? Can you guys go ahead and find X and tell me what value that's going to be? going to be 1.028 minus 0.9941. You're going to do the subtraction first, and then you divide by 0.0038. And please tell me what would be the number we're going to get for this one. It could be something closer to, it should be between 8 and 11, because I pick a number somewhere here.
8.9.
8.9. Okay, that's going to be 8.9 grams. 8.9 grams. Right? That is the mass of the sugar in how many milliliters of soda sample? 100. Right? So that number you're going to write down here. Grams of sugar in 100 milliliter soda sample. You're going to write it down here. And you do the same thing just for your second soda sample right there. Okay? And in your report sheet, you have to show this calculation in this space provided. In the handout that you are going to turn in, this red information will not be there. Okay? Yes. And then the next question. Calculate the mass of sugar in a 12 fluid ounces can of each soda sample. Report your results, the table to the right. And we are given 12 fluid ounces equals 355 milliliters. Okay? So how do we do that one? So that equation form is given here, but let me show you again here. So we got 8.9 grams, right? So if you drank 12 ounces can, what's the amount of sugar going to be? So we have 8.9 grams in how many milliliters? 100. Excuse me. So you want to find out in a 12 fluid ounces, and then we are given 12 fluid ounces equals how many milliliters? 355. 355. So 355 milliliters. Fluid ounces cancel. So this will give you the amount. Okay. So can you tell me what's going to be the mass in grams? Going to be in 12 ounces. Close to 28. How much is going to be?
I got 31.59.
31.59. So 31.59 grams. So that's the mass of the sugar in a 12 fluid ounce can. So that you're going to write down here under column G. Calculate the grams of sugar in 12 fluid ounce sample. Okay? And then you will be given the actual grams of sugar in 12 fluid ounces. And for your 2 soda samples. So we can find out the percent error. How do we calculate the percent error? For 39 gram, let's see how to calculate the percent error.
After the value of H minus G over 100?
Exactly. So you will also given that here. How to calculate the percent error? H minus G. Column H. Your actual grams, 39 grams. G would be the calculated amount. You get the absolute value and then you divide by the actual amount 39 and times 100. So if you use that, that's going to be so let me write the percent error is going to be actual, which is going to be your 39 minus 31.59. You get the absolute value divided by 39 times 100. That will give you the percent error. Okay. So this is If you go by the decimal places, that should be fine. There would be no decimal places. Correct, and then 39 times 100% error. So you will do that for both soda samples. Okay? You can just stop.
Thank you, Jackson.